Hi there. So a student has asked me to do a problem like this. I'll show you a couple ways to do it. One way to do so is to go and separate the problem into other symbols using U's and V's and W's and so on. I'll use that first as it's really easier to follow that way. It is unfortunately, though, really a lot longer to write it out, but it at least is something that you can at least follow fairly simply. And then I'll do it again, but using a differential notation. There's an extra little bit at the end that once you compute a derivative, the most common thing we do with the derivative is to actually set it equal to 0 and solve the equation. So because of that, it's sort of expected that you rewrite your derivative, if it's possible, as a product or a quotient, because then it's very easy to set that equal to 0 and solve it for 0. So to show you what I mean, the first step is to notice that you can break this particular function, y as a function of t, into two factors. I'll call those factors u and v. Okay, so then next, we're going to write down the derivative rule if I had written it that way. So this is really the same as saying u times v. Then, when you want to know what the derivative is, that's the derivative of y in terms of t. You can also write that as y prime if you like. That then is equal to, by the product rule, it would be the first factor, which is u, times the derivative of the second factor. You guys often call it just like v prime. And then you add to it the second factor, which is v, times the derivative of the first factor, which is then u prime. Now, there is a problem with this notation. This is the reason I don't actually like prime notation for a lot of things. It's nice for those of you who really know what you're doing. And that is when you say prime, you're saying a derivative with respect to something. So it should be obvious what it is. In this case, hopefully, since y was a function of t, and u is a function of t, and v is a function of t, when I write primes down, it's very obvious that it means the derivative in terms of t. But if it isn't obvious, you can always write out long form, u times the derivative of v in terms of t, to make it very obvious, plus v times the derivative of u in terms of t. These become now two subproblems. I have to find out how to go about finding this derivative and this derivative. So let's now start a side problem. So let's find out what u is. So u, if you recall, u was the function 3t to the fourth. Yeah, you could see it right there. All right. And in fact, I'm going to bring this down a little bit. So, I'll bring not this down since I didn't do that right. Get rid of this. And it's just, oh, I still have that activated. That's why. I'll just bring this down a little bit. There we go. There we go. So now you can see it every time I turn that thing on. There. So then if that's what u is equal to, I want to know what the derivative of u was in terms of t. And that, based upon the notation I have so far, that's the same as u prime. To make it be a little shorter. Okay, so then to find this derivative, you notice that it's the derivative, and that derivative operator is being applied to 3 times t to the fourth. So that is the 3 comes out, and then you take the derivative of t to the fourth, which is, by the power rule, 4 the power, t the base. You reduce the power by 1, that's 3. And then we just simplify it to write 12 times t to the third. All right, so we now have that derivative. Okay. The next one is v was equal to 6t squared minus 7 cubed. Now this would require what's called the general power rule. So the general power rule, I'll write off to the side, is that the derivative in terms of a variable, let's say in this case x, and you want to take the derivative of, let's say, some function let's call that function for now w, and it's being raised to the power of n. That would then be n power, the base w. You reduce the power by 1, and then you take the derivative of that base in terms of x. I'm just going to apply that rule. So if I want to know what v prime is, that is the derivative of this v in terms of t, because that's what v is a function of. And that equals then, by the rule, it's 3 to the power. The base was 6t squared minus 7. You then reduce the power by 1, that is then 2. And then you multiply by the derivative of the base, which the base here, that's the w, that's the 6t squared minus 7. That derivative would then be 12t, because you would go and take 6 times the derivative of t squared, which is 2t, that's 12t, and then the derivative of negative 7 is 0, so it'd be 12t. And then you clean it up. You just don't leave it this way. You write in nice order. So you write all the constants first. So we have a 3 times a 12. So we have this 3 times this 12 in the product, the way I've written it. So that would be 36. And then you write the monomial next. So the monomial is the term that has only one thing in it. So that's that right there. So that is t. And then you multiply it by the binomial to a power. So then this whole thing here, that's the binomial raised to a power. So that's 6t squared minus 7 squared. Okay. That means I now have all the pieces to go back to the original problem way back here and find out what is the derivative of y in terms of t. I just have to replace right here and right here with what I have right here and right here. All right, good. Now you have that. I'll just go and move all this up so we can go write that down. So if you recall, we had that y is equal to, that was my, I forget. I forget, what was it? It was the 3t to the 4th. All right, so then that's the 3t to the 4th times 6t squared minus 7 cubed. That was my u times my v. So derivative of y in terms of t, that can be shorthand written as y prime because it's understood what the prime means. It's in terms of t in this problem. That would then be, it's u times v prime plus v times u prime. All I have to do then is just replace everything. So u was 3t to the 4th times v prime, which is 36t times 6t squared minus 7 quantity squared. And then I have plus, then I have v, which is 6t squared minus 7 cubed times u prime. And u prime was 12t cubed. Okay, there you go. That's the derivative, actually. That's the answer. But we just don't leave it this way. This is now, it's a matter of being kind of polite. No one writes the answer that way. It's just crazy to do so. So I'm just going to kind of clean things up a little bit by going and taking that expression, and we're going to write it as a product. Because remember, one of the things you always do with these things is you set the derivative equal to 0. It's a very critical stage. It's understood that you do it, although you're not told specifically to do it. You're just told to simplify the answer, but you're not told how to. So the rule here is if you can, you write it as a product. You take your quotients and your product rules, and you turn them back into products or quotients. So to do so, I'm going to take each of these products. I'm just going to rewrite them in a nice standard format. To do that, I write the constants first. So I have this constant times this constant. So 3 times 36, that would then be 108. You then have the monomials. That would be this term and this term. If you multiply those together, you get t to the 5th. And then you have the binomial left over, which is 6t squared minus 7. That thing was squared. I do the same thing with the second one. It would be the monomial, the constant 12 times the monomial, which is t cubed, times 6t squared minus 7 cubed. Okay, there you go. So that's it looks nicer. It's still, though, it's not really right. It's the correct derivative, but we just don't leave answers this way. If there is a way to turn this into a product, we do. And for product rules and quotient rules, you pretty much can always do it. So notice that there's a common factor among the constants. So 12 does actually go into 108. So there's a common factor of 12. Between the factors of t, there's t to the fifth and t cubed. There's a common factor of t cubed. Between the factor of 6t squared minus 7, there's a common factor of 6t squared minus 7 squared. So then we'll take that out of each product. So if you take 12t cubed times 6t squared minus 7 squared and divide it into the first product, 12 goes on 108 and goes 9 times. T cubed goes into t to the fifth and it goes and leaves you behind a t squared. And then 6t squared minus 7 quantity squared dividing into the same thing just cancels. So that's that part. Then I add. Then I divide this product into the second part of the sum add. So 12 goes to 12 cancels. T cubed goes into t cubed and cancels. 6t squared minus 7 quantity squared divides into 6t squared minus 7 quantity cubed by leaving behind 6t squared minus 7. And you take the power of 3, subtract the power of 2 to get the power of 1. And then we finally just clean that up one last time. That's 12t cubed times 6t squared minus 7 quantity squared times 9t squared plus 6t squared. That's 15t squared. And then you have minus 7. That's the answer. That's the answer that you want at the very, very end. Because it's very easy now to take this thing and say it's equal to 0. If you just leave the answer instead, like what you see right here, it's just not going to be terribly nice to set that equal to 0 and to solve it. You'll wind up doing what I just did anyway. So just out being polite, and also to save yourself from woe later on, it's better to leave the answer that way. On the test, I specifically ask you to write the answers as products and quotients if possible. So then this step on the test is critical, that you actually have to do it. And I think that's enough for that particular portion of the video. Now, what if you want to do it a different way? So there is an alternate way to do all this work. The only difference is writing. It's exactly the same. There's nothing new here. It's all the same. It's just how comfortable do you feel to write down the answer this way? So doing it using more concise notation. So if you start with y equals 3t to the fourth times 6t squared minus 7 cubed, one of the major problems that students have is all this introduction of alternate symbols, of u's and v's and w's and other things. Students get lost. So a way to get around that is to use the differential operator. It's just there to remind you what's the next derivative you need to compute. So I'll do that way. I want to know the derivative of y in terms of t. So that means I'm applying the differential operator, the derivative in terms of t, to the expression y. That means I apply the differential operator d dt to the expression 3t to the fourth times 6t squared minus 7, that quantity cubed. Okay, so then from there, I'm applying then the differential operator to a product. So I'll write down now the product rule. The product rule is you write down the first factor, t to the fourth, and then you take the derivative of, so we take the differential operator, and we apply it to 6t squared minus 7 cubed. Then we add, continuing with the product rule, the second factor, 6 t squared minus 7 cubed, and multiply it by the derivative in terms of t of the first factor, 3t to the fourth. Now, anytime you have the differential operator, you just do that derivative. Anything else, though, you recopy, and you maintain the operation that was between whatever the differential operator applies to and everything else. Notice here there's a multiplication. Notice here there's a multiplication. So this will then be 3t to the fourth times this derivative, which I just did. So to save space, I'll just write down. That would be then 6t squared minus 7 quantity squared times the derivative of the inside, which is 12t. Then I add to it 6t squared minus 7 quantity cubed times the derivative of 3t to the fourth, which is 12t cubed. And that is exactly what I have right up here. That's what this is. That's actually all of this. So you get back to the exact same step. It's just that you have to go through the process now of simplifying the products, pulling out the common factors to write the answer. So what I just did is just notationally a tad bit faster. Well, it's actually a lot bit faster. That's why in the book you'll notice that they don't do this anymore. They don't write down the U's and V's anymore after they first introduce it, because it's just better to write like that. So, but you can use either method to get the answer. It's just realize that if you use the first method, it does take more time, and you only have so much time on the test. So as long as you can write quickly, the first method is really fine for the test. If you don't write quickly, then you might want to just write precisely and concisely and use this better second technique. Okay, that's it. I believe it's enough for you.